All right, so what do we do here with this one? Well, we're going to see in this section several equations, okay, where we have fractions with variables in them. So we do the same thing we do with equations where there are no variables, but they're still fractions. We first find the least common denominator. Well, there's only one denominator, so that must be it. Okay, and then we multiply both sides of the equation by that least common denominator. So we'll get this. And the whole point of doing that is to cancel away the denominators so that we no longer have fractions. I'll get rid of those parentheses on the left. Now the problem is significantly easier. So I'll subtract 24. And then I will divide by -4. And that gives me positive 11 halves, or 5.5, however you want to do it. And of course, you check it on your calculator. Plug in the left side. Oh, wait, let me change colors so you can see better. Plug in the left side for y1, the right side for y2. Go to the table. See if they match when x is 5.5, or just go to the graph and find the intersection point. But that is how it's done. Now we'll do it again. First we find the LCD, but this time we're able to factor at least one denominator. So this guy will be 2 times v plus 4 when we factor him. The other denominator doesn't factor, it's already linear with no GCF. So the least common denominator needs to have a factor of 2 and a factor of v plus 4. And the other denominator says, I need a v plus 4. Well, it's already there, so don't worry about it. Okay, so now we multiply both sides by that least common denominator. And so we get 3 over 2 times v plus 4 times the, this guy here, 2 times v plus 4. Sorry about my handwriting. I don't know what the deal is. Okay, and then we also multiply it by the other term on the left, by that 1. So 1 times 2 times v plus 4. This becomes a little bit tedious, but it sure makes it a lot easier for you to tell what's going on if I write it out this way. Okay, so there's the 2 times v plus 4 I multiplied both sides of the equation by. Yes, for the purpose of canceling away any and all denominators. So we're left with 3 from that first term, and then 1 minus 1 times 2 times, well, it's all there. So -2 times that will be minus 2v minus 8 when I multiply that out. And then on the right side, I just get 6 times 2 is 12. And this is not looking nearly as bad now that we've gotten rid of the fractions. So combining like terms on the left, I get -5. And if I add 5 to both sides, I get that. And then dividing both sides by -2, I get -17 halves, or -8.5. And you can, as always, double check that by plugging in the left side for y1, the right side for y2, and go into the graph and see where they intersect. All right, same thing again. Start by finding the least common denominator, and to do that, I need to factor the denominators. Well, the second and third denominators are linear with no GCF, so they don't factor. So that's nice. The first one, though, is very likely factors, and it's going to be u minus 5, u plus or minus 2. All right, so we go build the least common denominator, which, let's see, the first denominator says I need a u minus 5 and a u minus 2. Got it. Second denominator says I need a u minus 5. Well, it's already there. Don't worry about it. Third denominator says I need a u minus 2. It's already there. Don't worry about it. So we've got our LCD. So let's multiply both sides of the equation by the least common denominator. All right. Now this next step is that long one, and you can, I mean, if you feel comfortable with it, I suppose you could skip it. Okay. So we've got 7 over. I'm going to try and write this small-ish. It's kind of difficult with the stylus. Let me use alternate colors too. Okay, then I multiply by the u minus 5 and the u minus 2. Okay, then I've got my equal sign, and then 1 over u minus 5 gets multiplied by the LCD. Yeah, it's tedious. And then plus that last fraction. I think the next time I do one of these on this video, I'm just going to do the shortcut. I think you guys will like that. Okay, so that's what I'm doing. And for the purpose of canceling away all of these denominators. So what are we left with? Well, on the left side of the equation, 7. Cool. On the right side, we get 1 times u minus 2 is u minus 2. And then 3 times u minus 5 is 3u minus 15. We combine like terms on the left side and get 4u minus 17. I'm going to add 17 to both sides and get, not that, 24 equals 4u. Divide by 4 and I get 6. Okay, now, that's something I should have mentioned on the last couple, but I didn't. I just wanted to focus on the process. But anytime you have an equation, with variables in the denominator, you have to check your answer. Okay, that's why, down here it says if there's no solution, click on no solution. You might think, well, I mean, I'm always going to get an answer. Well, yeah, but does the answer actually work? Okay, is it a real answer? And so you have to check it. Okay, you got to check it. Now, we can tell by the denominators. If we set those denominators equal to 0, we can tell that, well, yeah, the variable cannot equal 5 or 2. If it equals 5 or 2, the deal is off. That's an equal sign. Because it'll make at least one of the denominators equal to 0. And you're not allowed to divide by 0. It doesn't work out. It doesn't work. It doesn't make sense. So, yeah, so you have to check your answers. Let's do that now. I'm going to plug 6 in for all of the u's, but I'm going to do it on the calculator. And first, I'm going to plug in the left side for y1 and the right side for y2. I'll meet you in just a moment when I get done typing that. Okay, so there I have it all typed into the calculator. And I believe the answer is 6. So one thing I can do is just go to the table and go down to x equals 6. Let's see if they match. They do match. So I know I've got the right answer. It's guaranteed at this point. If I want to explore this on the graph, it can be a little tricky. Okay. because there are variables in the denominators. So I can go second, trace, 5, and then 3 enters. 1, 2, 3, but it doesn't work. Okay. Why doesn't it work? Well, when the variables in the denominator, there are certain numbers that you're not allowed to plug in. In this case, they were 5 and 2. Those create what are called asymptotes. So at x equals 2, right here, the line, the blue line gets all squiggly, and so does the red one. And same thing over here when x is 5. Okay, the blue line splits into 2 pieces. So, so you have to be on the correct side of those imaginary lines, those asymptotes. So if in order for the calculator to find the intersection point. So if I go second trace 5, I say, all right, well, it looks like they intersect right around here, the blue and the red. So I'm gonna move it over with the right arrow. Okay, there. Now I'll do my 3 enters, and I get the 6 right there. Okay. So yeah. All right, and we do the same thing again. We factor the denominators. So u minus, this is difference of squares, so I get u minus 4, u plus 4. Now the denominators are factored. I determine my least common denominator, which is going to be u minus 4, u plus 4. And the whole point of getting the least common denominator is so I can multiply both sides by that least common denominator so that I can get rid of the fractions. So all of this so far, every time, is to get rid of the fractions. Okay, I promised I'd start doing the shortcut. Okay, instead of writing it out the long way. So for the first fraction, I can cancel the u minus 4 and the u plus 4 so that I will be left with just 3u squared. All right, for the second one, I can cancel the u minus 4s and I'll be left with 3 and u plus 4, which will be 3u plus 12. And for the last fraction, I can cancel the u plus 4s. I'm left with 4u times u minus 4, which will be 4u squared minus 16u. So what's different about this one? Well, now we've got a quadratic. Highest power of x is 2. All right, well, we know how to solve those. I'll tell you what, why don't we subtract 3u squared from both sides? Okay, that'll give me u squared. So that takes care of that guy and that guy. Okay. Then I've got 3u minus 16u is minus 13u. And then that just leaves a plus 2. Now I can factor the right side. And, oh, wait a minute, that was a 12. Okay, I was gonna say this doesn't factor. There, now it does. U minus 12, u minus 1. You can use the AC method or whatever. Set each factor equal to 0. And we get 12 and 1 for our answers. Okay. But do those answers work? I've got variables in the denominators, so I have to check it. Well, I can tell by looking at the denominators that the numbers that are out of bounds are positive and negative 4. Okay, well, my answers weren't positive or negative 4, so everything should be fine. Okay, but still a good idea to plug in the 12 and the 1, you know, just to make sure. Okay, on this one, there's only one denominator, so that must be the LCD. So I'll multiply both sides. Multiply both sides by that denominator. The i's cancel, and I get IR infrared equals E. And it says, go ahead and solve for I. Well, I had to multiply by I to get it out of the denominator so I could actually access it. Or in Spanish, this is pronounced ir. Okay, so divide by R to get the I by itself. and I equals E over R. And there's an example of that one. Okay, on this one, we're going to solve for D sub 2. So there are 4 distinct variables. There is W, L, D1, or pronounced D sub 1, and D sub 2, or D2. It's not D times 2 or D times 1. It's just a way of distinguishing between 2 different values of D. Like, for example, maybe D stands for the diameter of a circle. And we say, hey, we've got one diameter, we have another diameter, and we want to distinguish them. So we just say diameter number 1, diameter number 2. Okay. Let's see. Well, let's get rid of that denominator because that makes it easier. So multiply by the denominator. Those are gone. I get LW is 8 times D1 minus D2 in parentheses. But to access, okay, so to access that D2, it helped to get rid of the denominator. Now it'll help to get rid of the parentheses. So I'll multiply the 8 through the parentheses. Now I will subtract 8D1 from both sides with incredibly impressive penmanship, and oops, equals negative 8D2. Okay, now I just need to divide both sides by negative 8, and D2 is this. And I could kind of, tidy things up. Maybe, if I felt like it, I could divide that negative 8 into the LW and also into the 8D1. But I don't need to worry about that. That's how it's done. So I had to get rid of that denominator and the parentheses. All right, so on this one, we're solving for C. So we could just get away with multiplying by C only, but you know what? Let's multiply both sides by the least common denominator and get rid of all the fractions. Okay, so that'll give us DBC equals, and then for this guy, the B's will cancel, and I'm left with 5C. And for this last fraction, the C's cancel, and I'm left with 9B. Okay, now we still want to solve for C. So, but now we've got, so the C is out of the denominator, but now we have a new problem. C appears twice in the problem. So to handle that, you get all the terms with C on one side of the equation. And then any terms that don't have C, keep them on the other side. And now what do? Well, we think of the F word. We factor. So I'll factor C out of the 2 terms on the left. And now look what happened. I now have a single C in the problem. And now all I got to do is divide by DB minus 5. And there it is, 9B over DB minus 5. So yeah, it's a really easy step getting from here to here, but most people don't think of it on these problems. I don't know why, but I was the same way. You just have to say, oh yeah, I got to factor out the C, and then that way I'm down from 2 C's to 1, and then I can just divide at that point.